Hello YouTube. Today I would like to show you that the regenerative acceleration generator effect can also be employed in a normal microwave oven transformer, this transformer. So, one moment. In the previous video I've used this homemade transformer with a high current primary coil and a very high impedance secondary coil. So, but instead of it, today we will use this normal microwave oven transformer with a normal high current primary coil and a very high impedance secondary coil. So here are the specifications. 231.2 millihenries at the primary coil, and the secondary coil has 25 henries. So what I will do is that I will show two different settings, one running at 200 Hz and one running at 950 Hz, and you can see what the differences will be. So in this case, in this experiment, we will use no special parts. It's only a normal frequency drive controller and a normal microwave oven transformer. So okay, let's start it up. What I can do is put my camera over here. First I will start my frequency drive controller to 200 Hz. So here you can see that by now my frequency drive controller is running at 200 Hz, and that there is 5.9 volts going to the primary by now. So 5.9 volts and 200 Hz. So one moment, first let me try if my load is working. Okay, so for now you can see that on idle the system takes 17.2 watts by now, and when I connect my load to the very high impedance secondary coil, you can see that at 200 Hz the needed input power will increase to 17.5 watts. So now it's connected, 17.5 watts going to the primary by now, and now it's disconnected and it will drop to 17.1 watts. So what I can show is the scope shot, but for this is the scope shot at the top showing the voltage going to the primary, and the scope shot at the bottom is showing the current going to the primary, which I can show by using this 2.2 ohm series connected resistor to my primary coil. So for now it's disconnected, and when I connect my load you can see that normal transformer action is taking place because the current is shifting to the left. So now it's disconnected. What I can do is make it more sensitive. So now you can see that when we connect it, that the current is shifting to the left, and now the load is disconnected. So normal transformer action taking place at 200 Hz. Okay. Now I put my camera back on this position. One more thing, when we connect it, you see the same effect taking place, 17.5 watts, disconnected, it will drop to 17.2 watts, and when we disconnect the primary coil, you can see that the frequency drive controller by itself needs 15.9 watts. Okay, so now we go to the second. I have to connect my primary again. And now I have to speed up my frequency drive controller to 950 Hz. So one moment. There we go. So now it goes to 950 Hz by now. It takes some time. But now it's running at 950 Hz, and you can see that for now there goes 24 volts to the primary, so 24 volts going to the primary at 950 Hz by now. So one moment, I will check if my light bulb is running properly. now I have to set my scope to a different setting. Okay, now you can see that on idle the primary coil and the frequency drive controller will need 18.8 watts, and when I connect my load to it you can see that it will drop to 18.5 watts by now. 18.6, 18.5. So when I disconnect it the power will increase, and when I connect it at 950 Hz you can see that it drops to 18.5 watts. So the same effect is taking place in this normal microwave oven transformer. For now what I will do is show you what is taking place on the scope at 950 Hz. So one moment. Now let me connect the... Now it's connected, the load, and now it's disconnected. You can see that the needed input current will stay at a 90 degrees phase angle. So there we go, and now it's disconnected. So it's exactly 90 degrees because this arrow at the top will show what the start of the voltage on the pulse width modulation is. So this arrow is very important, and when you compare this arrow to now the loaded condition you can see that it exactly runs at a 90 degrees phase angle. So now it's disconnected. So one more thing. 18.7 watts going to the primary by now, and the frequency drive controller. Load connected 18.5 watts, load disconnected it will climb to 18.8, and when the primary is removed, so now it will take 17.6 watts only to supply my frequency drive controller. So you can see that the Thane C Heins generator effect can also be employed when you use normal components, in this case a microwave oven transformer and a normal frequency drive controller. So this is very interesting, and this is what I wanted to show you today. One more thing. This is exactly the same but as in the previous video, but for now I have used normal microwave oven transformer in this case. So, and the load is running at 950 Hz. That was what I wanted to show you today. Okay, thanks for watching. Bye bye.